Okay. Before we get started, are there any questions? Oh, no, sorry. Oh, okay. Oh, I wasn't. So, about DNS security, there is a lot to say. There has not been a lot that's really been done in a useful fashion. But sort of like IPv6, it's believed that it's better to know what's coming if it comes. Let's see here. This is my Windows laptop. So the protocol itself was not designed to be secure, and sure as hell it's not. It's a trivial matter to either make a resolver believe that your response is the one it was waiting for, or to insert your data into someone else's cache as a side effect of them asking you some question. And there really is no validation model in the underlying protocol, and that makes it kind of dangerous to believe anything you hear from DNS. And I'd like to think that there are no more implementation bugs, but you know, now that of course, bind has always been perfect, but now that there are other implementations as well, we're having a good time doing interoperability testing at IETF meetings. And you know, Microsoft, to their credit, has been buying pizza for these because they recognize that this is an extraordinarily good form of testing for them. Although it tends to look bad when everybody else in the room can fix whatever the bug was that was just found right then and run the test over again, whereas they have to submit a bug report and come back 3 months later. For whatever reason, a laptop is not powerful enough to build their DNS products. But anyway, this is part of the seamy underside of the internet, which is, of course, why it makes such good fodder for this conference, because that's what people in this room do for a living. But you just that statement I made a moment ago is fundamental. You cannot believe what DNS tells you, and yet all of us do. So, you know, take, for example, a relationship between your SSH client and some server somewhere where there's nothing in your known hosts file for the server you're going to go to. So when you SSH to that host, it's going to say, gee, I just got a key that I've never seen before. Are you sure you want to add this to your known hosts file? Do you really want to connect to this guy? All of us just pretty much say yes. And there's no guarantee that the host you got that key from is the one that you think it is. It's pretty easy to get the A record that your SSH client sees to be something different from what the rest of the internet would see or what you think you're seeing. So, in case you didn't think you had enough things to worry about. Now, the e-commerce hole that corresponds to that one is fairly pluggable, in that when a browser goes to some web server somewhere and sees a key that it's never seen before, there's a certification authority that went along with that key, and that certification authority tends to be, that's not always, but it can be hardwired into the browser itself, so that when you get a key, your browser knows whether its manufacturer thinks it ought to be trusting that. And furthermore, it comes up with a pop-up that says, okay, I just saw a new host key, came from, you know, UUNet Communications or, you know, whatever. It came from some place, and this is the certification authority that, and my level of trust for them about that name, about the company name. It isn't just a host name anymore. And so we can hope that VeriSign and the other certification authorities are not going to allow Joe Random Cracker Incorporated to have a key that has some other company's name in it. But there's nothing like that for email, nothing like that for SSH. The rest of the stuff is pretty much wide open. And since there are so many script kiddie toys out there that have this functionality for polluting other people's caches or spoofing their resolvers so that the response they see isn't the one that they thought they were waiting for, or the one you thought they were waiting for. I've included some of them in the bind kit. I figure if they're going to be out there, we ought to have them too. But long ago, during the internet worm debacle, I was in favor of releasing the source code to Mr. Morris's tool. So a lot of people were against that. A lot of people are against this. I have been called a lot of names as a result of putting these kitty toys in the kit. I guess my skin is getting thicker. Anyway, you should download the kit and run these tools against your own servers just so you'll see how easy they are. Oops. Where do you want to go today? And of course, the tools that I get are at the bottom of the food chain. You know, these are things that were left on some compromised computer that didn't automatically delete themselves at the end of an attack. I'm sure that there are much better ones available that have not filtered their way to me yet. So, that's the problem statement. What are we doing about it? Well, in the usual internet way, a lot of different people are doing different things, and then in the center you have a bunch of people working on standards that are extraordinarily painful, both to work on and to wait for. The biggest effort that's been made by organized religion in this area is the public-private key system known as DNSSec. And this is pretty much a normal model that benefits from the DNS hierarchy itself, so that when you get a referral telling you that a given branch of the DNS tree should be reached through thus and so server, you also get some kind of a key that would help you verify that when you start talking to that host, you're really talking to the person that part of the tree was delegated to. And it starts usually from dot. The expectation is that someday we'll figure out who owns dot, and that person will sign it, and that the public key that corresponds to the actual signing key will be put on a T-shirt, and that whenever you want to verify, you can just look down. But dot will then not only sign itself, but it will sign its top-level domains like com and edu and net and so forth. And the owners of those domains, assuming they are different from the owner of the dot domain, which seems likely, will then sign the second-level names like vix.com or nanog.org. Public key that will allow you, and by no I mean you trust. You know, you got it from someplace you trust, like an IETF T-shirt. You typed it in, or somebody sent it to you as a secure attachment, or you got it from a secure web server, whatever it is. You've got some trusted key that is higher above or has transitive signatures between the name you want, or to the name you want, then you can figure out that the name that you're asking about really is securely owned by, this is going to get old, by the person who sent it to you. And that's a pretty good model. It's just a normal, straightforward application of public key technology to the DNS. It turns out that DNS is not amenable to this. So for example, when you want to express a signature, you have to make a funny thing that looks kind of like a resource record, but it isn't really. Well, some people say it is, some people say it isn't. It's that kind of resource record. Sorry, this microphone is not going well. To give you an example, the signature is not unique. And normally, if you know the name, class, and type of a resource record, then you know the name of the resource record set of which it is a part. And for a signature, that's not true. You have to dip into the first short word of the our data section to get the type covered field out as well. So it's actually a quadruple, not a tuple, that identifies it. And that really violates the model in some interesting ways that have taken, I mean, not interesting, subtle. It takes years sometimes for the implications of those kinds of design decisions to make themselves known. And we're learning about them every day as we go to implement this stuff. And of course, dynamic updates will someday be covered by this technology as well. At the moment, the protocol development has been mostly in the area of queries. There has been some effort to extend this to include dynamic updates, but it is significantly less further along. So I mentioned that there are a lot of different people doing different things, and this is more or less what I did in response to the slowness that I perceived in the standards body that generates the public-private stuff. And TSIG is all about sneakernet. It proceeds from the assumption that in a LAN or a campus, it's usually going to be possible to distribute a key by wandering around with a floppy, or reading it to somebody over the phone, or something else that absolutely will not scale to the size of the internet, but would work pretty well inside my company. And as such, it has not been a popular standard. People, at least in the standards body, there is a preference for something that could run everywhere and solve everybody's problem. This can run everywhere and solve that person's problem, which is subtle but different. Now, SneakerNet is fine. It's especially fine if you don't include clients in it. I mean, most of us have one or two DHCP servers and one or two DNS servers, and walking around to those four machines to have them share some secret is just fine. And it's also just fine to have those things not have user accounts on them. Presumably, if only sysadmins can log in, then you can have relatively secure key storage. This key has to be held. Well, it doesn't have to be, but it tends to be held in clear text on the disk drive of the people who are using it. That's going to make it very difficult for Resolve.conf. If you wanted to use this for queries on your LAN so that your clients would all know how to go about trusting the responses they got from the recursive name servers, that would pretty much mean that Resolve.conf would have to have the shared secret in it, because it would have to be a world-readable file on hosts that have users on it, and that's not going to be popular either. So I have to admit that a public-private key system makes more sense, and TSIG was originally developed for dynamic update and zone transfer. In Microsoft Windows 2000, they're going to kind of abandon wins in a way. And here's somebody clapping. That was my first reaction, but what it turns out that they're doing is to embrace and extend TSIG. So one of the things Wins could do that DNS could not do at the time that Wins was developed was have a server come up and announce to the network, I'm here, these are the services I provide. If somebody comes to runs around and starts to want to know who is the Exchange server, who is the file server, tell them it's me. And DNS didn't have any functionality like that at that time. It does now, but there isn't a good security model for it, which is to say that for Microsoft, the average campus is thousands of machines, not dozens or hundreds, as in my personal case. So they did not believe in the transaction signature distributed with shared secrets distributed by TrueLeather and SneakerNet and so forth. So they developed something called GSS TSIG, which is kind of the public-private thing applied to transaction signatures, but it uses a proprietary key format that is based on their proprietary key format for their version of Kerberos. So there's a problem in the people who want to sell against Microsoft into some of these corporate lands, because they won't be able to come up with a server that is based on open source simply because Microsoft doesn't want that to be possible. So we're still fighting that out. There have been two sets of RFCs describing DNSSec, which is the first standard I described, the public-private sort of hierarchical key system. And the first one had a lot of problems, the second one has some problems, and it's natural for RFCs to go through this kind of gradual improvement. What's a little bit not natural is that a fair number of the people who are now implementing these standards didn't even bother to comment on some of the early RFCs, either because they weren't in the DNS industry yet, or they were busy with other stuff, or some of the concepts being argued were more important to security people than they were important to DNS people. And so it's created kind of a marginal situation where, you know, we at the Internet Software Consortium are getting around to implementing this stuff and discovering that there are a lot of ways in which it literally cannot work. So there will be at least one more RFC before we're done. As to whether the other RFC is going to be a complete replacement or just sort of another add-on or another series of add-ons, there have been some add-ons. I don't know. But the point is, this is taking a long time. We've been at it for at least 3 or 4 years, and we're not close yet. TSIG, on the other hand, has not been published as an RFC yet. It's been held up by a lot of really, you know, perfectly valid criticisms of the approach and of the details. It is, on the other hand, implemented in Bind 8.2. Both of these things are implemented, but I will caution anyone to really plan on experimenting with the DNSSec part, but don't plan on going into production with it in a worldwide fashion until Bind version 9. But the TSIG stuff is as ready as it will ever be, and we are using it, and it's got some rough edges that we'll be filing off in the next 8.2 cut. But fundamentally, you can secure zone transfers and you can secure dynamic updates using TSIG. And you can, within the limits of your ability to exchange keys with other second and further level domain holders, you can use this DNSSec code as well. So, for example, we exchange secure DNS information with John Gilmore's site and periodically with TIS Labs, who's the other person working on this with us. Export control was a huge debacle for us. The Clinton administration has not been friendly to the idea that, gee, if the rest of the world has code to do RSA, then American companies are merely being hurt if they can't also export it. There's been all sorts of code that you could import but not export. And there was a kind of a landmark ruling a few weeks ago pertaining to all of this, but I haven't really decided how I feel about that yet, because it's clearly going to go through another couple of appeals. It's going to go to the Supreme Court. There's no way the government's going to back down based on a circuit court appeal ruling. And so, be that as it may, we have proceeded independently from all that. It turns out that the Bureau of Export Administration, BXA, has this serpentine, Byzantine set of regulations about what you can and cannot do and what order you have to do things in and so on. So you can apply for an exemption. Basically, that's where you admit that these are munitions, that they are dangerous, but you then marginalize them and say that they aren't that dangerous, and could you please have permission to ship them even though it's arguably illegal. So you start by putting both knees on the ground and your hands together. And they're allowed to do a number of things, including say no. But if they say no, then there's an appeals process. And they could eventually have to explain why they had to say no. They're also allowed to not answer. or at least not answer for some number of months, which would be bad for us because the ISC's funding model kind of depends on getting this code out. So there is another approach, which is what we took, which is where you do a self-certification, where you, instead of asking their permission, you send them a letter saying, look, I've got this code, looks like it fits some of your guidelines. We don't think it fits them all. We're just going to ship it. If you have a problem with that, let us know. Now, the form of them letting you know is not that they send the marshals after me and handcuff me and take me away. It's that they would send us a cease and desist letter and say, you're a bad dog, and we'll talk about this later, but for now we want you to pull the code down. And we have received no such letter. It's not an indication that we won't, but so far we haven't, and we're into our third major tarball that has all this code in it. So at the moment I'm starting to feel safe.
That's when they get you.
I know. That's the end of my prepared slides. Let me get rid of the sunglasses here because I can't see you. I'm hoping there will be questions, especially detailed technical questions from this obviously ones and zeros sensitive audience. Randy?
There's somebody running. I don't need a soundboard. Randy Bush, Vario. Paul, last week there was supposed to be a interoperability testing with TSIG and DNSSec in Stockholm, North Europe. Can you report on it?
There was supposed to be one. I was not there. But Oliver was there and Mark Costers was there, and they had the latest snapshot from us for that workshop. And
the rumors are not great. So I'm wondering if you had some actual facts.
I don't. They've been strangely quiet. It's as though they're sleeping off the effects of their journey or something like that. But I'm curious. Do you know who else has implemented TSIG that they could have been testing against?
I've just been, well, I'm going on rumor, I'm asking for facts.
Okay, I don't know more than you do. Wish I did.
Yeah, the rumors were not serious.
It's probably because they had no pizza.
I've had pizza in Stockholm, it's pretty good.
There has to be more than one question. Or not.
Well, thank you.